Hi all, welcome back to systemverilog sessions. In this video, I'm going to discuss about how to rate the functional coverage. So in the functional coverage, we have two types, right? Data-oriented coverage and control-oriented coverage. And in this video, we will see how to rate the data-oriented coverage, and we will see the control-oriented coverage in assertions. Okay. In the last video, I have told you that data-oriented coverage is fully test bench construct. That means we have to write it. We have to write the code for it. Like in code coverage, it will be collected automatically by using the simulation tools, right? But we have to write the code to get the data oriented coverage. So to get the data oriented coverage, we have to write the cover group and cover points and cross coverage. We will see what this cover group and cover points in this video. Okay. And what is this cover group? The cover group is a user defined construct that encapsulates the coverage model specification. The cover group is a user defined construct that encapsulates coverage model specification. What is this coverage model specification? Coverage model specifies what signals we are going to track during the simulation, or what values we are going to track during the simulation or during the test. Okay, so this cover group is a keyword. We will encapsulate the coverage model specification inside the cover group and end group keyword. How we will write the interface signals in the interface? Similarly, we will write the coverage model specification inside the cover group construct. Okay, this is a keyword, and cover group and end group, and inside that we will write the coverage model specification. And the cover group construct can be instantiated multiple times in various contexts using the new operator. So we can instantiate the cover group multiple times by using the new operator. How we will instantiate the class? By using new operator. Similarly, we can instantiate the cover group multiple times by using the new operator. And a cover group can be defined in program block, class, module or interface. We can write the cover group inside the program, class, module or interface. Okay. And the cover group includes a set of coverage points, cross coverage between coverage points, a clocking event that synchronizes the coverage point sampling, coverage options and optional formal arguments. So this cover group includes, I told you that we will encapsulate the coverage model specification inside the cover group, right? So this coverage model specification includes all these points. So a set of coverage points. Coverage points is nothing but a signals or variables, which signal we are going to track during the test. So those signals are nothing but coverage points. Okay, it's also called as cover points. We will see in the next slide. Okay, and cross coverage between coverage points. Cross coverage in the sense combination of values between two or more cover points or coverage points. Okay, so that is cross coverage. We will see everything in detail. Okay, and a clocking event that synchronizes the coverage point sampling. Clocking event in the sense, so at what time we have to sample the coverage points, that will be defined by using the clocking event. Whether you have to sample the coverage points during negative edge or pause edge, this is nothing but a clocking event. And coverage options. So these coverage options are used to control the behavior of cover group, cover points and cross coverage. So we will see everything in detail. And optional formal arguments means we can pass the arguments in the cover group. Okay, so these things we can include in the cover group. Now we will see the syntax to write cover groups. So the first one is basic cover group syntax, and this is how to write the basic cover group, coverage model name and end group. So these cover group and end group are the keyword, and inside that we will write the coverage model specification. And for this coverage model name, we can create multiple instances by using the new operator. Okay, this is how to write the basic cover group. And list of arguments in cover group, we can pass the arguments to the cover group. How? Cover group CG. So in the parenthesis we have to pass the arguments, and while creating the memory, that means while creating the instance, we have to pass the arguments. Okay, so new of list of arguments, this arguments is nothing but here coverage CG list of arguments. So based on the arguments, the operation will be performed. Okay, next one is cover group syntax with clocking event. So clocking event means it will tell you at what time you have to sample the cover points. Okay, when you have to sample the cover points, that will be defined by using the clocking event. So how to write cover group coverage model name at clocking event. So after the name of the cover group, then you have to use the at clocking event. So at passage clock or at negage clock. So at that time the cover point will be sampled. Okay, and everything is same: coverage model name, coverage instance and new operator. Now we will see the cover point. So we know that inside the cover group we can include multiple coverage points. So those coverage points are nothing but cover point. Okay, so what is cover point? A cover point is an integral expression or variable that has to be covered on sampling the cover group. A cover point is an integral expression or variable that has to be covered on sampling the cover group. So these cover points are nothing but variables or expression. Okay, for example, in your design you have address and data, and you want to track those signals during the test. whether the specific value has hit or not, that you want to check during the test. That time how you have to define that variables by using the cover point. Okay, cover point data, cover point address, so that those variable will be covered when we sample the cover group. Okay, and a cover group can have one or more coverage points that can be labeled. That means inside the cover group we can include multiple cover points and we can give the name for it. Okay, we can label the cover point, and each cover point is associated with single or multiple bins that can be explicitly defined. So each cover point is associated with single or multiple bins. So what is this bins? Bins is a keyword. Okay, it is used to define the specific value or specific ranges of values to the cover point. So we will see what is bins in the next slide. So we will remember that each cover point is associated with single or multiple bins. Okay, and this is the syntax to write cover point, cover group, and inside the cover group how we will write the cover point, and this is the variable name. Okay, cover point name, for example cover point address, cover point data, and this is the label. We know that cover group can have one or more coverage points that can be labeled. So this is the label, you can give any name. Okay, and colon, label, colon, cover point, and the cover, that variable, semicolon. This is how to write the cover point. And this is the example, cover group CG at passage clock. So here I'm using the clocking event. So at passage clock my cover group will be sampled, and this is the label CP1 colon and cover point address CP2 cover point data. Okay, this is the example to write the cover group. Now we will see bins in functional coverage. So in the last slide I have told you that each cover point is associated with single or multiple bins, right? So what is this bins? Bins is a keyword. Okay, so bins in functional coverage are used to define the specific values or ranges of values for a cover point that need to be monitored during the simulation. So bins is nothing but it is used to define the specific value or ranges of values for a cover point. Okay, and the construct bins provide a facility to create a set of bins for a particular range or all possible values in the range for the mentioned cover point variable. Okay, this is the definition for bins. And the bins can be generated automatically or explicitly. So we can generate the bins in two ways, automatically or explicitly. So automatically generated bins are called implicit bins and explicitly generated bins are called explicit bins. Okay, so we will discuss in detail in the next slide. And the bins can be excluded or ignored from the coverage. That means we can exclude or ignore the values from being counted in the coverage by using the ignored bins. Okay, so here we can define the conditions to exclude specific value or range of value from being counted in the coverage, so that the defined value will not be counted in the coverage. And bins can also be marked as illegal. So by using the illegal bins we can mark the value as illegal value. Okay, so bins is nothing but it is a keyword, it is used to define the values, right? So we can make the value as illegal by using the illegal bins. Okay, so we will discuss all types of bins in detail in next coming slides. Okay, and the syntax to write bins is like this: cover group name, and cover point label. This is the cover point name, and here is the bins. So bins is a keyword which is used to define the specific value or ranges of values for a cover point. Okay, so this is the definition of bins, and here you can see multiple bins I have created. So each cover point is associated with single or multiple bins. Okay, so end group. Now we will see example with implicit bins declaration. So what is implicit bins? In the last slide I have told you that automatically generated bins are called as implicit bins. Automatically generated bins are called as implicit bins, but how the bins will be created automatically, we will see in this example. Okay, so here I have a module functional coverage, and inside the module I have three variables: address, data, and enable. So here it's important to know the bit width of variable. Okay, so this will tell you how many implicit bins will be generated for the variable. Okay, here I have a cover group. C group is the name of the cover group, and CP1, CP2, CP3 are the labels of the cover point, and cover point address, cover point data, cover point enable. So if you want to cover the value of that variable, then you have to mention the variable as cover point, because cover point is nothing but a integral expression or variable. Okay, so if you don't declare the variable as cover point, then that variable or signal will not be monitored during the coverage. Okay, and here I am creating the instance for the cover group C group. So CG is the handle of the C group, and I'm creating the instance by using the new operator. And here I'm sampling the cover group by calling the sample method, cg.sample. Okay, so when I call this method, the cover group will be sampled. Okay, so this is the example, and here you can see I'm not using any bins keyword. it is what it is, implicit bins, right? So implicit means bins will be created automatically. So how the bins will be created automatically and how many bins will be created, we will see. So here I told you that the number of bins will be depends on the bit width of the variable. For example, address is 4 bits. So how many possible values address can have? 2 to the power 4. 16 values address can have. So 16 bins we can generate. Okay, 16 implicit bins will be created for address variable, and for data 2 to the power 3, because data is of 3 bits. So 2 to the power 3 bins, implicit bins will be created for data cover point, and for enable cover point, enable is a single bit cover point. So 2 to the power 1 is 2. So 2 implicit bins will be generated for cover point n. Okay. So here for address, cp1 dot auto of 0 to cp1 auto of 15. So these names you can see in the coverage report. Okay, no need to write anything because this is a implicit bins. So it depends on the 2 to the power bit width. So 2 to the power bit width is equals to number of implicit bins of that variable. Okay, so for data is of 3 bits, that's why 2 to the power 3, 8 implicit bins will be created. And for enable is a single bit, 2 to the power 1 is equals to 2 implicit bins will be created. So this is how the implicit bins will be generated for cover point. Okay, now we will see example with explicit bins declaration. So what is explicit bins? We know that automatically generated bins are called as implicit bins. Similarly, explicitly generated bins are called as explicit bins. So explicit means we have to manually define the bins for the cover point. We have to manually define the specific value or ranges of values to the bins of the cover point. Okay, we will see how to generate the explicit bins for the coverage specification. So here I have a example. It's same as previous example. Okay, functional coverage and 3 variables cover group. So if you see here, cover point address bins, I'm using the keyword bins to generate the explicit bins. And what is bins? Bins is used to define the specific values or ranges of values to the cover point. And when you don't want to cover all the values of the variable, then you can go for the explicit bins by defining the specific values. Because in the implicit bins, we know that bins will be created automatically for all possible values of the variable. If the variable has 5 bits, then 2 to the power 5, 32 bins will be created for cover point, right? So automatically bins will be created for the cover point. But in the explicit bins, you can track only specific values, right? So here for example 1 10 12, only when you give this any of these 3 value to the variable address, then this b1 will be counted in the coverage. Okay, only these 3 values it will track, not all the possible values of the address. I'm just considering these bins. Okay, I'm not considering other bins, I'm just giving the example. So the specified value will be tracked during the coverage. And there are 2 types of bins in explicit bins. One is scalar bins and one is vector bins. So you know, right, what is scalar and vector. In the arrays, I have already explained what is scalar and vector. Scalar means single quantity or single object. Vector means set of quantity or group of objects. Okay, so this is the first one is scalar bins. What is scalar bins? Scalar bins declaration creates a single bin for all the values or ranges specified by the bin definition. Scalar bins declaration creates single bins for all the values or ranges specified by the bin definition. This is called as a bin definition. B1 equals to 1, 10, 12. This is called as a bin definition. And here I have only B1, right? There is no size or anything. So B1 is there. This is the scalar bin. It will create the single bin for all of these values. Okay, so here I have 1 10 12, 3 elements. So when you provide any of these 3 value to the variable address, then this bin b1 will be counted in the coverage. Okay, so it will create single bin for 3 values. And this is vector bins. So if you define the bins as like this, b2 square bracket, then this is called as a vector bins. Okay, here you can provide the size also, and you don't have to provide the size also, anything is fine. Okay, so what is vector bins? Vector bins declaration creates individual bins for each of the integral values specified by the bin definition. Vector bins declaration creates individual bins for each of the integral values specified by the bin definition. That means here I have 2 elements in the set. How many elements are there? 2 elements. 2 down to 9 is 1 element and 11 is 1 element. So when the size is not specified or fixed in the vector bins, then it will create the bins which is equals to the number of elements in the set. Okay, here I have 2 elements. So 2 bins will be created because size is not fixed here. So when the size is not fixed, the number of bins will be equal to the number of elements. Okay, here since I have 2 elements, 2 bins will be created. And in the third definition, bins B3 of 4. here size is fixed or size is specified, right? So that many number of bins will be created. So B3 of 4 means 4 bins will be created, but I have only one element, 0 down to 7, right? So this 0 down to 7, how many elements are there? 8 elements. So 8 elements will be equally divided for each bin. Since I have 4 bins and 8 elements, two values will be allocated for each of the bin. Okay, so if you see the table here for the cover point address, the first definition is bins b1 equals to 1, 10, 12. So it constructs the single bin for 1, 10, 12 value, right? So this is the scalar bin. So only one bin will be created for all the three values. So if you give any of these three value to the variable address, then this bins b1 will be counted in the coverage. And the second definition is bins b2, 2 down to 9 and 11. So here this is the vector bins because we have a square bracket and size is not specific. That's why it will create the two bins, constructs two bins, that is b2 of 0, b2 of 1. And the first element goes to the first bins and the second element goes to the second bins. And the third definition is B3 of 4. Bins B3 of 4 means here size is fixed. So 4 bins will be created. B3 of 0, B3 of 1, B3 of 2, B3 of 3. And how the elements will be allocated for each bin? This is the range, right? 0 down to 7 means 8 elements. So elements will be equally divided for each bin. Since I have 4 bins and 8 elements, each bin will get two values. Okay, B3 of 0 will get 0 to 1 and B3 of 1 will get 2 to 3 and the second bin will get 4 to 5 and the last bin will get 6 to 7. So two values will be allocated for each bins. Okay, and so if you give any 0 or 1 to the address, then this B3 of 0 will be counted in the coverage or hit in the coverage. Okay. And one important thing to remember in vector bins is when the size is fixed for the vector bins, we have to divide the elements equally for each bin. Okay, here I have a even number of elements, 0 down to 7 means 8 elements I have, so I can easily divide two values for each bins. But what if I have odd numbers? For example, here I have 0 down to 7 and comma one value like 10 I have. Okay, totally 9 elements this set has. That time I cannot divide the 9 values equally for the 4 bins. So the last bin will get the remaining value. Okay, 0 to 1 for the B3 of 0, 2 to 3 for B3 of 1, 4 to 5 for B3 of 2 and B3 will get 6, 7 and that 10 value. Okay, so the last bin will get the remaining values when the size is not when the number of elements is not equal to even number. Okay, and you have to consider the total elements. If you have 0 down to 7 comma 10, then it is not a 2 element. Okay, it will be 9 elements. Okay, when the size is not specific, then only the bins will be equal to the number of elements. Here the comma will separate the elements, but when the size is fixed, you have to count all the values in the range as well as in the separate element. Okay, specific element also you have to consider with the range values. So 0 down to 7 will be 8 elements when the size is fixed, and you have to divide the elements equally. And if it is not equally divided, then you have to the last bin will get the remaining values. Okay, this is one thing you have to remember. And next one is data cover point. So in the cover point data, the first definition is bins b1 equals to 4 comma dollar. So 4 comma dollar means what? Maximum size, right? And what is the maximum size? Data has 3 bits. 2 to the power 3 is 8. So 0 down to 7. 7 is the maximum size. That's why it constructs the single bin for 4 to 7. Okay, from 4 to 7, 4, 5, 6, 7. If any of the 4 value is provided for the data variable, then this b1 will be counted. Bins b1 4 down to dollar. Okay, and the next definition is bins b2 of vector, right? So this is the vector bins, and 2, 3, 6. How many bins it will create? I have 3 elements and size is not specific. That's why 3 bins will be created. B2 of 0, B2 of 1, B2 of 2. 2, 3, 6. And the last one is cover point n. So n is a single bit variable, and here the definition is bins b1 equals to 1. So it constructs the single bin for value 1. Okay, you can specifically mention the values like this, or you can provide the ranges of values when it has a more than 1 bits. So this is about the explicit bins, and I have an example in the next slide. How many bins will be created and what are the values of each bin for the following coverage specification. Okay, so just analyze this and try to give the answer in the comments. Thank you.